Mike, thank you for joining us. Thank you for a very interesting presentation. Looking back at 2017, what would you identify as the key developments in Europe in the market?
Well, there are many because there are many different technologies, but the one that excites me most is the FS Found project, which is basically a gravity-based foundation. 5 of those were floated out and sunk at the Blythe Offshore Demonstrator and now have Vestas or Mitsubishi Vestas turbines, 164 metre diameter turbines operating on them. So I think this makes a major change between foundations relying on vessels to be installed, and now they can be installed by tugs effectively.
In your presentation you also talked about the potential for gravity-based foundations with turbines installed.
Yes, so the one I just mentioned was a gravity-based foundation, merely for the foundation being floated out and sunk. There is another project that's underway that's called ELISA, which is going to be installed in the Canary Islands, and that's a more sophisticated one in the sense that it has the turbine on the foundation as it's floated out. It has quite a complicated sort of telescopic type design, so it's quite compact when it's floated out, and then it's extended when it reaches its site. So that looks very interesting.
Yeah.
We'll see what happens with that. It's not quite such a large mainstream turbine on there, but it will make a major contribution to our understanding about whether that type of thing can work.
In terms of the new larger turbines, are we looking at incremental increase of the type that we've seen before, or do you think there's a revolutionary development out there? Are we going to see a big leap forward in turbine size in the next 3 to 5 years?
I don't think so, in a sense that there have been major increases in turbine sizes, and they're all big leaps. The increase in rating that's happening is more minor in the sense that it's not going from 2 to 6 as we saw before, or 4 to 6, or which was major steps. They're smaller steps, and the rotor sizes aren't changing enormously because we're talking about, as they increase the rotor size, it's swept area that increases. So we're not looking about majorly longer blades, but they are significantly longer blades, and the innovations that go into them have been significant too.
Yes. Now, as we know, almost all existing wind farms are bottom fixed, with the exception of projects such as Hywind Scotland.
Yes.
Can you tell us a little bit more about the potential of floating offshore wind? There are a number of demonstration projects coming up, but how soon might it be before we're actually talking about building floating wind farms?
Okay, so for commercial ones, I think, well, they're still a way off. I mean, Hywind is a UK project. It's a spar buoy design. But I don't expect to see that commercially exploited in the UK because we have lots of shallower sites which are more economic to develop, and those will be developed first. So I don't think we're even going to get to floating. I did do an analysis once that said if we had a 40 gigawatt market in the UK, then you might get floating that's between 8 and 16, something of that order. So I think it does depend very much on the market size. So it's other places, I think Japan particularly, where they don't have an alternative. They have a small amount of space that they can do fixed bottom. But it's those sort of places where, floating offers them something, i.e. a source of renewable power. So,
but I guess that also speaks to the need for demonstration projects to prove the technology.
Oh yeah, they're brilliant. So not knocking it. The Statoil project, the Buck and Deep Hywind project is brilliant. It's a great demonstration, and but I don't think it's going to be used. That technology is used much in the UK market.
Right. Do you see potential in other European markets or in the Mediterranean, perhaps?
Mediterranean, yes. I mean, that still has some narrow, sort of shallow sites. It's quite deep. The wind resource isn't so brilliant. I mean, one project that I'm particularly passionate about is the idea of having floating and the production of clean water. And I think in the Greek islands that works. It doesn't need to be such a large. It's a different type of installation. 2 megawatt sort of turbines might work very nicely with that. I think Portugal is an interesting one. Yeah. It does have deeper water. It has less of the shallow water sites. Of any European country, that's most likely to be the one that's most interested in floating. But we'll see. I mean, there is the south coast of France as well, and there are some various French sites that are there for demonstration, and we'll see where they go. Again, you know, if you were France, you also have the choice between some shallow sites in the north and the west. So, you know, how does that trade-off work?
France is an interesting market in as much as there have been contracts awarded for fixed bottom wind farms.
Yes.
But they're not being built yet.
Yes.
But now they're getting into floating offshore wind. So how do you see the future of floating offshore wind in France?
Well, yeah, I think I alluded to it because it's difficult to say. Because floating generally, and in my talk I talked about this, we're expecting to see a reduction in cost of that, in levelized costs, quite a dramatic one. But if you like, the control sample is conventional offshore wind, which is getting cheaper as well. So it really has to accelerate, and I think this is a challenge for things like airborne. In order to be successful, they have to achieve a dramatic reduction in cost of energy in order to keep pace and outperform the current industry and the rate at which it's the levelized cost of energy is reducing. I think overall, I'm expecting to see by 2030 projects that come to decisions in 2030. I'm expecting to be about 30% cheaper than they are now.
So that's quite a big ask.
Yeah,
for the technologies.
Well, exactly, and so disruptive technology really has to be disruptive and achieve significant cost reductions, because they can't rest on any laurels or assume that they're competing against something that isn't dynamically reducing its cost, because it is.
You've referred briefly in your presentation to going further offshore and the logistical challenges of doing so. Can you tell us a little bit more about what kinds of potential solutions are being looked at that you think might be applicable?
Yes, I mean, the further you go offshore, and indeed the trend is to going further offshore. That said, there are further sites that might not be quite so far offshore, but that may come up for development. But you're starting to think about having to base the people who service the turbines offshore more. So you're talking about what's called a flotel, these types of vessels. So you may see more of that happening, so they don't have to travel the distances, and particularly Dogger Bank projects will have to have a very different approach to how you get people, personnel there.
You
and
might see a
back.
semi-submersible, perhaps like in the oil and gas industry, the big semi-submersible accommodation platforms that accommodate 1,000 people.
I think that's quite possible, and I think that makes a lot of sense, because the key thing is being able to and maybe possibly platforms like that, possibly vessels that are designed so the vessel overnight will move to another part of the wind farm, ready for to disembark people at a short distance to the actual turbines.
Yes. And one last thing, you talked about airborne earlier. What might be, how far away are we from airborne? Can you tell us a little bit about the airborne project that you mentioned, the demonstrator, and about the implications, if any, for the supply chain of airborne?
Yes. So I think what airborne does is it means that you don't have to resist all the forces. At the moment, a conventional turbine has to resist a lot of forces, and therefore a lot of its cost is in resisting those forces to keep the rotor where it is. So effectively airborne, you get the rotor without having to resist so many of those forces. So it looks to be inherently cheaper, but it has to deliver. It has to be able to operate regularly. It has to be robust. It has to be able to work autonomously. It has to be able to land and come back again. So lots of big core challenges. But if they are met, it does look like a game changer. And in terms of the industry, where you're still going to need foundations, you're still going to need cables, etc. The foundation may not need to be as big to cope with these larger conventional turbines that we're seeing, but it may be something that, so maybe the amount of innovation that happens to happen on those is smaller. You may be able to go back to using some of the vessels you've given up using, but again, it depends what the optimal size of kite is.
Yes.
So you may want to go to larger kites. The advantage of them is that the load on the foundation is less, so it doesn't have to be so substantial. But it's finding that neat point where the kite is at its optimal performance.
So there'd still be supply chain opportunities, but they'd be different.
Oh, definitely. And I think if you're talking about cost of energy reducing, that means that the market cake effectively is going to get bigger.
Yes.
So although you might have a smaller share of that cake, possibly, it's still going to be a bigger cake. So I think in terms of, we're talking about growth, whatever, it's just suggested that the type of growth
Yes.
we're describing going forward.